This is our last type of transformation, our last group of transformations in this section. Again, this is section 1.6, day 1. The vertical stretch or shrink is going to be pretty straightforward. That's something that you've done in the past in Algebra 2. However, the trickiest one of all, any of these transformations that we're doing, is horizontal stretch and shrink. And so I want to focus on that mainly when we're doing these, but it's worthwhile taking a look at the vertical ones as well. First, let's start with vertical. All you need to do when you're performing a vertical stretch is multiply the function by a number out in front. If that is a factor that's larger than 1, if it's a big number, then it does a stretch. If it's a small number, like a fraction, then it does a shrink. Here's an example of a vertical stretch. So the green one is my original, and as you can see, I am pulling that vertically. I'm stretching it out. So like this point goes up to here, this point goes down to here. I'm stretching all those out vertically. I'm making the y values, I'm multiplying the y values so that they go taller, skinnier in that case. Horizontal stretches and shrinks. One thing that's super important about this is that you keep horizontal stretch and shrink in this form, x over c. This one's going to kind of seem backwards for what seems logical, because I'm going to do x divided by c, and if I'm dividing by a number, we're going to find out that it's actually a stretch. If we are multiplying by a number, which is the same as dividing by a fraction, we're going to find that it's a shrink. And it's really opposite to what we would normally think, and we'll see that in the examples coming up. Horizontal shrink, here's an example of what that would look like. The green again is the original, and so I'm shrinking it this way to get the new one as you see in there. On to the examples. Here is the first example that we'll be dealing with horizontal stretch and shrink. We've got an equation to consider. This is like our parent function, and we're going to modify it in certain ways. So number one, what is the equation of g of x with a horizontal stretch by a factor of 3? Now, important to know again how the horizontal stretch and shrink work. It's in the form x over c. So you see we have this formula here that's going to work out for us. So x over c, we have a horizontal stretch by a factor of 3. We're just going to plug this in to each spot that we have here in the original function that you see. So I'm going to plug this in, x over 3 cubed plus 4 times x over 3. That will perform a horizontal stretch of this graph. You can try it by putting this into y1 on your calculator, put this into y2, and just notice that this one will be stretched horizontally compared to what we had in there. Next stretch shrink is number 2. What's the equation of g of x with a vertical stretch by a factor of 3? If we're going to do a vertical stretch, it's multiplying the entire equation out here by some number just right out in front. So we've got 3 times g of x here. I'm going to put the g of x part in parentheses. And then since this is a pretty simple one, I'm just going to go ahead and distribute. So 3x cubed plus 12x, and that would represent a taller, skinnier graph from the original multiplied by 3. This one I didn't bother to distribute because we really don't need to go any further with this, but you just need to know what that does to the graph, the horizontal stretch. Last one is a little bit strange, as you can see. What's the equation of g of x with a horizontal shrink by a factor of 1/2? So remember I told you it's got to be in the form x over c, so that's why you see this kind of weird notation going on. That means, so we've got here x over 1/2. Now, we've talked about before how when you divide by a fraction, it's the same thing as multiplying by a reciprocal. So I think what's a good idea to do with this one, if you're going to get that equation in there, is change this into something that doesn't involve a complex fraction. Dividing by 1/2 is the same thing as multiplying by 2. So this could be rearranged as 2x. So I'm going to rewrite this just to make it simpler, g of 2x instead. Much easier to write the equation from that. Then I'm going to just plug the 2x into any x that I have up here. So that's going to be 2x cubed plus 4 times 2x. And I could simplify this if I want. It's not super necessary in this case, but it'd be 8x cubed plus 8x for this one. And that should represent a horizontal shrink by a factor of 1/2. And again, if you're not sure if it is, go ahead and put it in your graphing calculator. Put the original in y1, put the new one in y2, or whatever one you want to put it in, so that you can graph that. Now I do have one more example before we're done with vertical and horizontal stretch and shrink, and that is to take a look at these equations, take a look at this equation and decide how does that identify the vertical and horizontal stretch shrink in comparison to the basic function. So we've got absolute value of x. So each one of these we're going to be comparing what happens with vertical and horizontal stretch. And I kind of like to just do vertical stretch first just because it's easiest at this point. So the fact that we're multiplying by 2 means that we have a vertical stretch by a factor of 2. This is where it gets tricky, that 3x. Remember that this is horizontal if it's on the inside. If it's 3x, we want it actually to be in the form x over c. So let's think about how that relates to 3x. I want x divided by something. So you have to ask yourself, x divided by what fraction gives me 3x? Well, the reciprocal of 3 is 1/3. So we're going to have x over 1/3 in that case. Now this is the factor, which means that it's a small number, it's a shrink, and so we'll call this a horizontal shrink by a factor of 1/3. So again, that's a little different than you might think. We're multiplying by 3, you would think, wow, that stretches. It actually does the opposite, it shrinks. One more to think about, and that is 1/2 times the absolute value of x over 3. Again, the one out in front's maybe a little easier to use. The 1/2 for the vertical, that means that we're going to have a vertical shrink by a factor of 1/2. Anything that's less than 1 is going to be a shrink. For this one right here, we again have to think about the form x over c, and that's already in that form. It's x over 3. So we look at this number down here, that determines if it's going to be stretch or shrink. Since 3 is larger than 1, this is a horizontal stretch by a factor of 3. So whenever we're commenting on vertical or horizontal stretch or shrink, we say stretch or shrink, and then by a factor of what? And so that's how you see what I'm doing right there.